Let us understand NoSQL data modeling and explore schema design principles for NoSQL databases. NoSQL data modeling is about how you structure and organize data in a NoSQL database. Here are some key characteristics of NoSQL data modeling. NoSQL databases often use schema-free or flexible schema designs. It allows you to store different types of data in the same collection. They also use denormalization and data duplication to optimize the speed of data retrieval. NoSQL databases are optimized for specific query patterns. This means the way you store your data is influenced by how you intend to retrieve it. These databases are designed for horizontal scalability. This allows you to handle large volumes of data and traffic. Performance is more important than consistency in NoSQL databases. This means data might not be instantly consistent across all parts of the database, but it is fast. Let's discuss the major NoSQL database types. First are document stores. Examples include MongoDB and CouchDB. These store data as JSON-like documents, are schema-free with nested structures, and are suitable for content management and event logging. Their modeling focuses on embedding versus referencing. Second are key-value stores. Examples include Redis and DynamoDB. They feature a simple key-value pair structure, are extremely fast for simple operations, and are good for caching and session management. Their modeling focuses on key design patterns. Third are column family stores with examples like Cassandra and HBase. Data is stored in column families, optimized for high write throughput, and suitable for time series and IoT data. Their modeling focuses on column family design. Finally, graph databases such as Neo4j and JanusGraph store nodes and relationships, optimized for connected data. They are good for social networks and recommendations with modeling focusing on entity relationships. Let's delve into the core principles of NoSQL data modeling. First is the query-first approach. Design your data model based on how you will query the data, not just how to store it. Start by identifying the access patterns your application needs. For example, to design for a specific query pattern such as finding all orders for customer X, you might structure your data as follows. Here, the customer ID is C1001, and the orders are listed with their respective order IDs and dates. Next is denormalization. Embrace data duplication to optimize read performance. Unlike relational databases, NoSQL databases often store redundant data to minimize joins and complex queries. For example, to denormalize product data, you might duplicate product information in each order. Here, the order ID is 0123, with customer details and item details including product ID, name, and price all listed within the same document. Here are more core principles of NoSQL data modeling. Consider embedding versus referencing. Choose between embedding related data within a document or referencing it. Embedding improves read performance but can lead to large documents. For example, an embedding approach for a blog might look like this. The blog ID is B123, with the title NoSQL Best Practices, and comments embedded directly within the blog document. Consider composite keys. Design smart keys that encode multiple attributes to enable efficient querying and sorting. This is especially important for key-value and column family stores. For example, for a composite key design, you might format the key as user ID :year :month :day. The value associated with the key would then include activity details, duration, and device information. Let's explore the final core principles of NoSQL data modeling. Data aggregation. Pre-aggregate data to optimize for common queries. Store computed values rather than calculating them on the fly for better performance. For example, consider pre-aggregated metrics such as the total sales, average rating, and review count stored directly within a product document. This allows for quick retrieval of these metrics without needing to calculate them each time. Polyglot persistence. Use multiple database types for different parts of your application. Choose the right database for each specific data access pattern. For example, you might use MongoDB for a product catalog, Redis for session data, and Neo4j for product recommendations. Here is an example of document store modeling with MongoDB. Consider an e-commerce product catalog. A document store like MongoDB is ideal for product catalogs with varying attributes across different product categories. An electronics product document might look like this. It includes details such as the ID, name, category, price, and specifications specific to electronics. Modeling relationships. Choose between embedding related data or using references based on access patterns and data size. For products with few reviews, you might embed the reviews directly within the product document. For products with many reviews, you might use references, storing reviews as separate documents and linking them to the product. Here is a look at key value and column family store modeling. Key value store, Redis. Optimize for fast lookups with carefully designed keys. Ideal for caching, session management, and real-time analytics. You can set session data with expiration using the set and expire commands. You can also maintain a counter for page views using the incr command. For a leaderboard, you can use a sorted set with the ZADD command. Column family store, Cassandra. Designed for write-heavy workloads with efficient partitioning. Ideal for time series data, IoT applications, and event logging. You can create a table for user activity tracking by time. The row key is the user ID, and the column family is activities. Column names are timestamps, and values are activity details. Let's see graph database modeling with the social network example, Neo4j. Model relationships as first-class citizens. Ideal for social networks, recommendation engines, and knowledge graphs. You can create user nodes with names and ages. You can create relationships to show who is friends with whom. Recommendation engine. Use graph traversal to find complex patterns and relationships. Powerful for finding connections that would be difficult with other database types. Here we can find friends of friends who Alice doesn't know yet. Let's conclude by reviewing best practices and common pitfalls. Best practices include starting with query patterns, designing for specific access patterns, embracing denormalization, using composite keys, considering data lifecycle and growth patterns, and implementing versioning for schema evolution. Common pitfalls include treating NoSQL like a relational database, creating overly complex data structures, ignoring data size limitations, overusing joins or lookups in document databases, neglecting consistency requirements, and failing to plan for eventual consistency implications. Key takeaways. NoSQL modeling is query-driven, not structure-driven. Choose the right database type for your specific use case. Understand the trade-offs between consistency and performance. Consider polyglot persistence for complex applications. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.